All right, well, let's do a couple more derivatives. I want you guys to realize how these rules can be used. And that's important because now that you have these rules for trig functions, well, we now have all kinds of new problems that we can do. So here's another problem. Here's another equation. We got y equals x squared the sine of x. Y equals x squared the sine of x. We're going to try to find the derivative. Honestly, that's going to pretty much be the directions about 90% of the time over the next many weeks. Find the derivative. Okay, now maybe the sine is catching your attention. I hope that it's a big takeaway from this class that the derivative of sine is cosine. Pretty neat idea. However, as neat as that is, this is really what needs to grab your attention. See that big yellow dot? Okay, I can make it a little bigger if you don't see it. But it is supposed to be representing the fact that this is a product. This is a product. Now, kind of know, because I've taught this before, that for some reason, products are hard for kids to see. Okay, now if you're like, I see it, it's fine. Well, then make sure you use the product rule. You have to use the product rule to do the derivative of x squared times sine. Again, that's the other big takeaway of this. You have to use the product rule. Now, remember that product rule? You might kind of be wondering or trying to remember, because we didn't use it too much. We've only been doing this for about a section or so. But when you use the product rule, it's the first derivative of the second plus the second derivative of the first. Okay, that's going to be a lot different than just doing the derivative of both these terms. So, ready? That's the first. I kind of just copied it down. First derivative of sine. Okay, well, the derivative of sine is cosine. That'll be the first one that you rattle off. And then you want to add the second derivative of the first. Now, here's the second. I just kind of copied it down. The derivative of the first is the derivative of x squared. Of course, that's the old bring down the exponent thing. Now, you'll notice that I wrote the answer in that order. And that's kind of the way I want you to get in the habit of doing it from now on. Because basically, when you write it this way, there's confusion. There can be confusion about the sine of x or the sine of x 2x. And so we always put a polynomial in front of a trig function. So there's not confusion about what's attached and not attached. Okay? It's not wrong. It's just that it's better this way. Okay, so product rule.
If you put parentheses around it too.
Yeah, if you do that, I'm going to give you credit on the test. Okay, but if you don't do that, then we'll kind of be like, well, do you know for sure what your answer represents? So that's fine. This, again, you'll see this in the solution manual. It's just a little bit more proper. Let me put this one over here, a little space. So we had a product rule. How about if you have a quotient, like this cosine divided by 1 minus sine? Okay, now, again, when you have a quotient, you have to use the quotient rule. It's usually a little bit easier for students to see the quotient because it's obviously a fraction. But again, I have to use the quotient rule in order to do the derivative. Okay, remember, kind of big mistake. You can't just do the derivative of the numerator and denominator. A couple of you did that a time or two. Make sure you learn from that. You don't do the derivative of the numerator and denominator. Rather, you use the quotient rule. Okay? Ho-de hi minus hi-de ho all over ho-ho, or bottom derivative of the top. Okay, bottom, derivative of the top. Now the derivative of the top is minus sine. Another reason I want you to memorize those rules sooner than later is because then you can use them. You don't have to like look at them. So get them memorized, rattle them off. Okay, and then of course minus top derivative of the bottom. Top derivative of the bottom. Now when you do the derivative of the bottom, that's the derivative of 1. Well, that just becomes 0. Now the derivative of sine is cosine, but there's still a minus sign here. That doesn't kind of disappear. So it's really like 0 minus cosine. Easier said to be negative cosine. So again, the derivative of sine is cosine, but again, there's a negative coefficient that comes along here. Don't forget the Santa Claus part, the ho-ho, all over ho-ho. And I'm kind of wondering, as you look at this, if you're maybe projecting a little bit to the future here about what might happen. But as you get a little bit sharper with math, you start to see things like sine squared, okay, like cosine squared. All right, now you saw it happen before lunch, but again, if you see squares coming, sort of popping up, well, just be ready because you never know what you might be able to do with that identity. Now I'm going to distribute negative sign into the parentheses, so I get negative sine. I also get a positive sine squared. And then we're going to multiply these negative cosines to get a cosine squared. So we get negative sine plus sine squared plus cosine squared. Notice the denominator, I'm just leaving it in factored form. There's not many times I can think where you want to like FOIL the denominator and somehow it makes the answer simpler. Okay, a lot of times you just leave it in factored form. But sine squared plus cosine squared, there it is again. Okay, pretty nice. Okay, now remember that equals 1 from last year. That equals 1. A lot of calculus is algebra. Okay, I think the great Yogi Berra, the calculus theologian, said that something like 99% of calculus is half algebra or something like that, because basically we're doing more algebra to finish this problem. The calculus was done when we wrote the quotient rule down, but there's more algebra here. Maybe you notice that the top and bottom are identical. If you don't notice that, let me rewrite the top. Just simply 1 minus sign. And then if you look at the bottom, now I know I said that you never want to FOIL the bottom. I'm not foiling it, but I am kind of expanding it a little bit so that it's easy to see that these are going to cancel. So since they cancel, why not? We end up with a simpler derivative. 1 over 1 minus sine. 1 over 1 minus sine. Okay, now remember, that's a derivative. That's a formula. Tomorrow we'll do some stuff with the formula, but basically I could plug in x. When you plug in x, out pops the slope. Okay, but we'll do some of that tomorrow. Try one. Just kind of curious what you'll do with the derivative of 3x plus x cubed secant x. It doesn't necessarily have a trick to it, but you do have to think about some of the things I've showed you the last 10 minutes. I don't want this to be a reason that you're unsure. So in case you need me to tell you, you basically can do the derivative of both of these terms. That was kind of one of the first things we learned, where you can just, anything separated with plus and minus signs, I can individually do the derivative. So you're trying to do the derivative of 3x, and then you're trying to do the derivative of x cubed secant x. This is the kind of problem that I wish it was a little easier for you guys to like talk to each other, because you might find out, that what you have is the same as someone. Maybe you'll find out that, oh, I forgot something. If you want to compare, you want to talk about it, turn around, share. Just before I go over the answer, maybe you just want to see if you can learn something, from someone. dy dx stands for the derivative of y with respect to x. It's just a notation. It's like a symbol. Okay, it actually will have some more meaning as we go through the year, but it does stand for the derivative of y with respect to x. Now, the derivative of 3x, hope you didn't make too much out of that. The derivative of 3x is 3. But you have to do it. You have to change it to 3. Now, I see some of you comparing and you're shaking your head yes. I hope that both of you saw that product. I hope you saw that product. If you didn't see that product, make sure you see it so you can use the product rule. Now, the product rule says that you're going to write down the first and then do the derivative of secant, the derivative of the second. Now, the derivative of secant, we usually just kind of rattle off and say secant tangent. That's right, but it's secant of x, tangent of x. I don't make you say that unless you want to. So it's both of those. So x cubed times secant x times tangent x. And then you're going to do the second derivative of the first. The second, you just copy down secant, but the derivative of the first is one of these polynomials. It's nice to write it in front, so we get 3x squared. Okay, that's it. That answer is totally fine. Now I'm just going to show you something because the solution manual likes to do this. Now listen, it's something that maybe will be helpful for another problem. Right now I'm just kind of showing it to you and saying it's not necessarily any better. It is true that there's some stuff here, we call them terms, actually we call them factors, that you could pull out, you could factor out. Okay, if you factor out an x squared and a secant, because that's what's common, I guess we call it like the greatest common factor, then you sort of get a little different looking answer. It's just in factored form. You would get an x tangent, okay, because that's what's left over, and then over here you would get just a 3. As I said, you don't need to do that. I'm not going to like get in an argument that you have to do that. I do know there's some problems somewhere that we do where you will want to factor it because maybe something cancels. Something cancels because maybe there's like a denominator. Obviously, there's no denominator for this problem, so nothing's going to cancel. But sometimes factoring can help you to do another step. Okay, like I said, the solution manual likes to factor, and sometimes you can just go back one line and you can check your answer and you're fine. All right. A couple more things to do tomorrow. But as I said, you'll probably find maybe before lunch or maybe after lunch that you can start your assignment. We might finish, during the half period before lunch. Even though it's a 2-hour delay, we still have a full class period. So please plan accordingly.